So this is a classic position, velocity, acceleration set of questions. And for that reason, I've included this diagram here in the concepts side. These things here on the right in blue are the concepts that we have to make sure we understand. They're giving us velocity as a function of time. That means if they ask us a question about acceleration, we're going to have to differentiate it. If they ask us a question about position, we're going to have to integrate it. I also want to add just one more diagram because I think it's sometimes helpful for some students to understand, and that is this is all about motion of something that is moving back and forward along the x-axis. Okay? But if you wanted to graph it in two dimensions, you'd make your vertical axis x and your horizontal axis t. And so this is really saying that as time progresses, this moves backwards and forwards along the x-axis. Okay, let's, with that additional diagram, let's go ahead and jump into part A. They want to know whether the speed is increasing or decreasing. Now we've made use of this concept diagram, and speed increasing and decreasing requires a table or something similar here. And that is, when velocity and acceleration are both the same, either both positive or down here both negative, then we have increasing speed. But when the velocity and the acceleration have opposite signs, that's the region of decreasing speed. So we simply need to find what the velocity is at time 4, what the acceleration is at time 4, and see which pattern they fit. Remembering that the acceleration is the derivative of the velocity. So I've got my calculator here, and I've already put in the formula 1 plus 2 sine x squared over 2 into y1 because I'm going to be referencing it throughout the problem, and I don't want to have to input it multiple times. Okay? So what do I need to do? First, they want to know the velocity at time 4. Well, I can reference y1 like this, and then I say just tell me what it is at t equals 4. 2.9787. But I also, so that's positive. But I also need to reference the acceleration. Well, the acceleration is the derivative, so I'll use Math 8. And again, I'll insert the velocity as the function. And we're also interested in knowing what acceleration, the derivative of velocity, is at time t equals 4. It's a negative number, negative 1.164. So that allows me to write this all up as follows. Namely, because the velocity is positive, the acceleration is negative, the speed is decreasing. All right, so in part B, the question is, when does the particle change direction? Again, remember, it's just moving backward and forward along the x-axis. Changing direction simply means the velocity is changing sign. So I'm just going to graph the velocity as a function of time and find the point where it crosses the time axis, the horizontal axis, moving from positive velocity to negative velocity, or from negative velocity to positive velocity. What do I need to do for that? Well, what should I make my window? Well, I'm going from t equals 0 to t equals 3. Again, I know this is sometimes confusing, but x is simply the horizontal axis, in our case the t-axis. And I can also read enough from this equation, 1 plus 2 sine. Since sine goes from negative 1 to 1, I know that the range of the height, basically the x variable, is going to go from negative 1 to 3. So let's just go ahead and graph that. And along the way, we're going to ask it to find zeros. Well, there we go. Looks like there's only one 0. So this makes it fairly easy. We'll make that our left bound. We'll make that our right bound and our guess. And we get a 0 of 2.7074. So we can write that up. So again, the velocity changes sign at approximately 2.7074. Notice that because no units are given in the question, I don't need to include units in my response. Let's try part C. So now in C, we're trying to find the position of the particle at a time different than the known position of the particle. We know where the particle is when t equals 4. We'd like to find it when t equals 0. And that is exactly what this form of the fundamental theorem is about. Namely, if you'd like to know the position of something at a new time, and you already know it at an old time, all you do is integrate the derivative of the position for the interval of time in between. And in this case, the derivative of the position, of course, is the velocity. Derivative of position is velocity. So all that is left to do is to write x of 0 equals x of 4 plus the integral from 4 to 0. Now normally I'd write x prime of t dt, but because x prime is in fact v of t, I'm just going to write it that way. Notice some people will get concerned about the fact that I'm doing an integral from 4 to 0, but this is all part of the system of integration where reversing the direction of integration simply gives you the opposite sign that you had before, and so it automatically takes into account the fact that we're starting at t equals 4 and going backwards in time to t equals 0. So again, let's put in the numbers that we have. We know that at x of 4, this number is 2, and so we'll just use Math 9 to find this number, and then we can write out the combined result. And I've done that right here on the calculator. So what we want is, we want to start at 2. We want to add to that the integral from 4 to 0. Of the velocity function, which again I can reference indirectly as y1. And that's my final answer, negative 3.8150. All that's left now is part D. D, we're finding the total distance traveled. Well, we simply need to recall that total distance traveled is a different kind of integral of the velocity. Namely, it's the absolute value of the velocity that we're integrating. This ensures that whether we're moving in this direction or this direction, we're always adding distance. So it is just as easy as writing that total distance traveled equals the integral from, in this case, we're going from t equals 0 to t equals 3 of the absolute value with respect to time of v of t. Notice it's a fatal mistake in almost every situation to put the absolute value outside and simply do the ordinary integral of velocity and then take the result and take the absolute value. We have to do it for each micro step, if you will, within the time interval. But we can easily calculate this again on the calculator referencing a y1. I'll just say math 9 from 0 to 3. And then putting in y1 is not what I want. What I want to do is make reference to the absolute value, which is the very first entry in the catalog. So I just go down to the catalog and choose the first entry, and now I put in the y1. And there's our answer, 5.3012.